20 वर्षाचे अस्तित्व, 2 विद्यापीठे, 23 शैक्षणिक संस्था, देव करत आहे 137 विविध अभ्यासक्रमे. रायसोनी ग्रुप, अ विजन बियॉन्ड.
A warm welcome to the audience, panelists, moderator, participants across platforms, cities, and interests. It's an honor to welcome you all to Industry Education Vertex 2021, a virtual panel discussion on engineering your career. I'm Smita Thote, the anchor for the event, and I extend my warm welcome to you once again. Guidance involves the difficult art of helping students to plan their own future wisely in the full light of all the factors that can be mastered about themselves and about the world in which they are to live and work. This was exactly the thought we had in our mind when we came up with GHR Career Connect, an initiative of RGI. Every year, we do it with thousands of children in mind who can make informed choices for their life ahead with the help of this. Today, we hope you will find answers to most queries you have in mind with the relevance to engineering as your education and career choice. It's an honor to introduce the moderator for the panel discussion today, Ms. Kritika Dhanwate. Kritika Dhanwate is a businesswoman with a degree in engineering and master's in science in sustainable building technology from the UK. She is director of KK Group of companies, which offers automatic vehicle cleaning machineries. Kritika is passionate about the environment, animal, and constantly working on eco-friendly techniques and technology. We are glad to have your presence and participation, Ms. Kritika. I would like to hand it over to you.
Thank you so much. Thank you for your kind words. First of all, I would like to thank Raisoni Group of Institutions for inviting me for this event as a moderator. I'm happy to be a part of this event under the GHR Career Connect. This initiative is a perfect guidance at the time when every student struggles for a good advice from the right people. What can you expect more when this program has such learned and experienced panel to guide the young brains ready to build the future? I would like to introduce our panelists, starting from Dr. V.M. Kadre. Dr. V.M. Kadre is a professor in Electrical Engineering Department in IIT Bombay. He has contributed more than 45 papers in different journals, 84 conference papers, and books. He has been working on a number of projects pursued along with the industry and has a long list of awards. Naming a few, SP Sukhatme Award for Excellence in Teaching, INSA Teaching Award, President's Gold Medal at IIT Delhi, and many more. It's an opportunity to interact with you, sir. Welcome, sir.
Thank you.
Our next panelist, Mr. Arvind Kumar, is the center head of Tata Consultancy Services in Nagpur. He has a dynamic personality and an extensive experience of 30 years. He has done his BTech in Computer Engineering from Indian Institute of Technology, Banaras Hindu University, Varanasi. He has taken up a number of roles over the years, starting as a technical team member to technical lead and a business relationship manager to the center head. We welcome you, sir.
Thank you.
Dr. O.G. Kakte. He is the director of Indian Institute of Information Technology, Nagpur. He has earned his PhD from VRC, Nagpur, and MTech from IIT Bombay. He has an immense experience and published papers in about 25 journals. He has also contributed and published about 5 books. And his main area of research is in language processors, computer programming languages, and advanced compiler construction. We welcome you, sir.
Thank you.
Mr. Nikhil Malhotra. He is the Chief Innovation Officer at Tech Mahindra and creator of Makers Lab. He is also an inspiring TEDx speaker and an author. He has been awarded the Aegis Gramble Award and ET Telecom Award. He has published a number of white papers and has a number of interesting articles on subjects like development, robotic companions, which are so relevant in testing times like this during the pandemic especially. We welcome Mr. Nikhil Malhotra.
Thanks, Mutina.
I'll introduce Dr. Manoj Daigane, sir. He is the Joint Director of Regional Directorate of Technical Education. He is also the Principal of Government Polytechnic Nagpur. He has an experience of more than 32 years in teaching and administration. He has published and contributed in 24 international journals, 30 international conferences, and a long list follows. A warm welcome to the program, and I'm glad to interact with all the panelists today. I'll just welcome Director of GHRC, Dr. Sachin sir also to the program. Just to start with, I'll just welcome with some, I want all of you to just give some initial remarks. To start with, Dr. B.M. Gadre, if you could just speak a few words before we start.
So, a very good afternoon to all the people who are attending this. We are all very happy to be with you this afternoon. Being in the academic field, and as Ms. Kritika said, having also been in contact with the industry through academic industry interaction largely, I have seen of course, much of the side of academics. That's been my large, sphere of action, so to speak. But I also know of the issues that relate to how we should be planning our education system in a way that we can connect to the industry. This is an issue which has always been foremost in our thoughts, particularly when we talk about employability and so on. I'm really glad today that I'm sitting on a panel with such distinguished members, many of whom can probably in fact enlighten me as well, in terms of what we can do better in terms of the academic sphere intersecting more with the professional world. And I would also be very happy to answer some of the questions which I've seen. I can see students have raised some very important questions. And actually, I'm just looking forward to this discussion from which I think I will also learn a great deal. So with these few words, I would now hand over to the other speakers.
Mr. Arvind Kumar, sir, please.
Yeah, thank you. Thank you, Ms. Kritika. And thank you, GH Raisoni Group, for inviting me for this particular interaction session. And I always believe that the interaction with the budding professionals should start early in the life cycle, professional life cycle. And I'm happy that GH Raisoni has organized this particular event because when we say that we are all experienced, right, whether from the academics or the industry as a professionals, so our experience is of use when we rub the shoulders with the youngsters and the next generation in the nation building. So I'm very, very happy that I'm getting this particular opportunity to interact with all the budding engineers, budding professionals, right from the very beginning, than actually start interacting in the third year and the fourth year. So thank you. Thanks a lot.
Thank you, sir. Dr. O.G. Kakre, sir, if you could just.
Yeah, thank you very much. Good afternoon, everybody. At the outset, let me thank Raisoni Group for giving me this opportunity. and I would like to share the little experience that I have gained over last more than 32 years, hoping that it will help the students in making an informed choice. Now, my dear students, you are at the crossroad. You have to make a choice of your career. And I feel that I should share some of the points that you should first understand to make an informed choice at this stage. So I will talk about 3-4 points because there is a limit of time also. I will be given 2-3 minutes only. So the first thing that you should understand is, what do you expect or what do you want out of education? The answer is probably a decent employment. No doubt, knowledge, values are also important, but they are all complementary. Decent living generally ensures everything else. Another point that you should understand is the era in which you are living. All of you knows that technological advancements are changing the way we lead our life, the way we transact our business, and therefore it is changing the employment landscape also. The pace of technological change have increased, and this is clear from the time gaps between the industrial evolutions that we witnessed. We know that the first industrial evolution began in 18th century, whereas second at the beginning of the 20th century, whereas the third one in the last few decades of the 20th century, and we are now in the midst of implementing the fourth industrial revolution. And today we are living in an era of disruptive technologies. If we look at the automation, the level of automation, it was there when I was doing my engineering, and what it is today, there is a huge difference. Now almost everything is going to get automated. If that is so, you must understand what industry is looking for. If everything is going to get automated, what industry is looking for? So I feel industry is looking for what you can bring to the desk which cannot be automated. And that is thinking. Hence, logical thinking and critical analysis are the most important things required for professional success, along with domain-specific skills. Next thing that you have to understand is, can you have a future-proof career? The answer to this is no. There is, or no career option offers a future-proof career, because the employment market has become very dynamic, and it has accelerated the shift in the required workforce skills, especially domain-specific skills. With the shelf life of the domain-specific skills coming down, with every technological intervention, you must understand that reskilling and upskilling will always be required throughout your professional lives. So if you understand these things, then you will be in a better position to make your choice of the career. Thank you very much.
Thank you so much, sir. Thank you, sir. We would also like to welcome Dr. Manoj Daigane, sir. We would welcome you to the panel.
Can you hear me?
Yes, yes. Sir, we have already introduced you to the rest of the panel, and
No issue, no issue. Go ahead, go ahead.
yes, sir, but I would want you to give your initial remarks about the whole event, like the complete topic. If you can just give a few remarks.
Hello, everyone. So, all dignitaries are present. Kakade sir, Gadre sir, Arvind Kumar sir. So, here I am representing the government. Even if what next after 12, and in my opinion, students are coming from schooling background and they are entering in new scenario of the admission. So they should be prepared that how to enter in this professional field and what are the different opportunities are there and how they select. So prior to this, they have to go for a competitive examination. That if I can talk about the MHT CET or MSCET. So well, already students applied and prepared. Even now they are getting the hall tickets and different centers are assigned to them. So continuously they should go to their login and see what is the status, which center they have assigned, and after going to this, what are the things going to come before them during CET, what type of subjects they are going to get, that if they want to go for engineering side, what combination they need to fill in the form, and then what type of questions based on the HSC, what contains, then SSC, how many percentage is given. Accordingly, they prepare for the CET, and because this is the crucial time so that they can enter in a different engineering college. So, and avenues are equally, even if emerging areas are there. So depending on their score, CET scores, they can enter in a college or they can choose a better college. So I will suggest the student prepare very sincerely for the CET so that they can choose the good college, those who are having, or which institutions are having good reputation, accreditation, NBA, and so on. So this is the opening remarks from my side.
Thank you, sir. Thank you so much. I would ask Mr. Nikhil Malhotra to give an introduction to the topic.
No, thanks, Kritika. And I think I've heard, from all the panelists, and I think there are fantastic comments. Number one, I must tell you, I'll give you the industry voice. Number two, I completely dabble between the research as well as the industry as my work as a Chief Innovation Officer for Tech Mahindra. And for students who are actually joining in, they can actually read about what we do. But I started my career with IBM and IBM Watson. Some of the first codes of Watson were actually written by me. I still like to think some of those codes are still running. Maybe that's a far off pitch that I look at. But what we do today and why it has changed and why it's important for students to look at and decide what's going on in the future is the very reason of the pandemic that has changed the way we look at the world. This pandemic today has made data scientists like me into virologists and vice versa. Virologists have changed into data scientists as well because we wanted to encounter through technology something which was unknown and was unseen by all of us as an epidemic that came to us. My whole ideology with the students and during this talk would be to actually tell them where the future lies. What should they be looking at and not looking at when they look at technology in the future? Where are some of the biggest changes that the industry now needs to see? Where are some of the biggest research areas that India today needs to have? And maybe make a choice based on that. It's absolutely not necessary to stick on one line. The industry needs a kind of an interdisciplinary approach when you now join the industry, and that will be my viewpoint, Kritika, when I speak. Thanks.
Before we start with the main questions, I would just like to inform the students that you can just post your questions to the chat box, and in the end, we'll just have a look at all the questions and try to answer as many as we can actually. So if it's okay, if everybody's fine, I'll just start with the questions. The first one, the very first question that would raise in any fresher's mind is why engineering? Dr. Gandre and Dr. Kakre, I would like your opinion on this point. We would request you to state just a few reasons why engineering is the best career choice as compared to the other careers, especially is there any other career choice which matches engineering, being both intellectually challenging and rewarding at the same time?
So should I go ahead or?
Yeah, please do, sir.
Yeah. I'll share with you a thought which I heard during my student days and which I think is still relevant today, in this context. there was a very experienced speaker who came and talked about this trichotomy, so to speak, science, technology, and engineering. So, if you take this trichotomy, so science, pure science, where you look for knowledge for its own sake at some level, right? Then you have technology, which translates science into systems which could possibly be implemented, and engineering, which actually takes knowledge from science and the ideas from technology and brings them on the ground, so to speak. So my understanding is that most students would be inclined and probably also competent to do this, right? I mean, they would, if you look at it philosophically, I mean, they would want to understand fundamental principles that science offers, go through the realms of technology to understand how these can, what implications these can have for systems or things that could possibly work, and then actually making them work by building those systems, right? So I would say that's philosophically one important reason why all students should be going, many students would want to go for engineering, particularly those who have this bent of mind. I wish to gain knowledge of fundamental principles. I wish to understand how these principles would apply to systems which would work. And then I would also want to see those systems being built so that they work. So I would start with this philosophical thought, and I'll now let Professor Kakade continue with his thoughts.
Yeah, I will be giving a rather pragmatic answer. In my opening remark itself, I have already made it clear. The students, what do the student want out of education? The pragmatic answer is a decent employment. So keeping that in mind, if you look at the engineering education, you will find that it develops logical thinking and critical analysis, along with development of the domain specific skills. And thereby, engineering graduates you will find are better decision makers, and hence they perform better in their personal life, irrespective of the sector they choose, because there are many engineering graduates into bureaucracy also and doing very well. Because administration has also becoming more and more specialist type of administration. This is supported by even statistics. If you look at the most common undergraduate degree amongst many successful managers, you will find it's an engineering degree. So engineering degree, I feel ensures better employment opportunities in all sectors vis-a-vis other career options. And the reason is, with every technological intervention, the level of automation is going up. And with the interventions of disruptive technologies, we are talking about like AI, ML, IoT, and so on, almost everything is going to get automated. And therefore, we find the better employment opportunities if are having an engineering degree. And that is the reason why engineering is the most sought after undergraduate degree. That's what I feel.
I agree with you, sir, on this point. The next question is to Mr. Nikhil Malhotra and Arvind Kumar, sir. What are some common misconceptions people have about engineering as a course when they start as a course or maybe as a career? The common misconception, like somebody thinks that, okay, I'll choose something very complicated engineering subject and that will give me like a big package to start with. So, but being from the industry, what is the ground reality when a person is actually choosing an engineering course on his basis of his skill?
So,
Arvind, go ahead after you. Yeah, go ahead, please.
thanks, Nikhil. So, Kritika, I would say that there is no complicated engineering or simple engineering. There can be complicated subject or simple subject. There could be complicated formulas and simple formulas, right? And when you develop a passion and interest, even those complicated, so-called complicated formulas and the subjects can also become simple. And it's all about going back to the roots. So if you go back to the roots and strengthen it, everything becomes simple. So there are various streams and engineering streams, and all are equally important. So can you, for example, just live and build beautiful buildings, bridges, and dams and so many beautiful structures without having civil engineering knowledge or architecture knowledge or design knowledge or have a sense of an aesthetics into it, right? So can you build heavy electrical machines without having electrical engineering knowledge? So every stream is important and every stream has a scope for an individual. It's all about that, do I have an interest? Do I have a passion? Do I have an inclinations towards solving the problems, right? So choose this stream. My suggestion would be that choose this stream based on your interest area. And yes, every stream, as Professor Kakade was mentioning, that every streams are looking for technology-led automation. So there is no classical mechanical engineering, right? So there is no classical electrical engineering or civil engineering or industrial engineering or chemical engineering, right? All streams have adopted the automation. All streams have adopted automation. So that means that we should learn certain courses of an automation along with mechanical engineering or civil or electrical or electronics engineering. That's very, very important. For example, mechanical engineering should be well versed with software tools like AutoCAD, SolidWorks, Creo, CATIA, some Adobe Creative Suites, right? And similar other design tools, right? Similarly, electronic engineering engineers should know MATLAB and similar other automation tools. So when you are choosing a core engineering branch, make sure that from the very first year itself, you also look into the fact that are there certain mechanisms and tools and techniques through which some things can be automated further. And that's the innovation and creativity. And that is the fun that you can bring in your passion and be relevant to whatever that disruptions or the changes that we are seeing around. So that's my viewpoint. Over to you, Nikhil.
No, I think I'll completely augment that, but I'll just do a flip side to this. If a student has a fallacy about what he wants to do with engineering, let it be there. Because we are at this point in time sitting where students need to create something completely outstanding out of India. And I'll equate it to the formula saying that most of the times we've always thought about the what and the how, but we've always missed the why. So if you have a fallacy, you are now being given tools during your engineering course to actually take that fallacy out and create that why value. And that is for a reason what Arvind is saying, or panelists before us, before him, as I actually said, that engineering will give you the art of creation. It's the act of creation which gives you satisfaction, and that's why you would have to choose your field in that specific manner. Number one. Number two, as Arvind rightly mentioned, every field of engineering or otherwise is going through a massive change and would continue to do that for the next decade. We are actually looking at AI, we are looking at ML at the moment, which is obviously very prevalent, but we would soon get into quantum world and we will start doing quantum computing as well. So there's a complete shift to that branch and to that value as well. You are seeing machines pass on a lot of data. Who would have thought Elon Musk sending a spacecraft or making a spacecraft beyond NASA? And back home in India, there's a startup set up in IIT, which is basically Agnikul. It's only because you are thinking about that why and you're getting ahead of your times. And you have those fallacies that I wanted to clear it. And that's why you're getting into these fields, right? So that's the second point. The third point is, I have enough examples working in my lab who have actually gotten no previous experience of engineering and education. And they're today working in the software world. And I've got an Uber driver who met me during his Uber drive and he wanted to do something in engineering. And I nonchalantly, as we normally say, I said, learn Python. And after 3 months, he had Python on his computer and he was sitting in our lab. He's now a permanent employee. Within 3 months or 6 months, he's gathered Python, C++, etc. So the first purpose that all these esteemed guests have said and the panelists have said, upwilling yourself is more important than upskilling, which is going to come later. And that is important for students. you'll have to approach this from a very different perspective, saying that I'm going to change the way India is looked at from a world's perspective. And you are the harbingers of that technology. You're going to change that by saying that I am going to produce new stuff. I am going to change the problem statements, and I'm going to change the definition of the problem statement itself. And that's why it's important. So any fallacies that you have, please do keep it in your mind and enter engineering, because you were the ones who are actually going to create those fallacies into reality.
Yeah, that's a very good opinion for especially the ones who are a bit confused at this point of time. Yeah. Dr. Daigavane sir, I have a question for you. What are some of the key points that you had mentioned a few when you started, but I'll still ask you the question point wise. What are some of the key points that a student should note while choosing the right engineering college? Would it be the placement record and the accreditations? Would it be the college industry connect and the projects associated? Or would it be the resources like the technological and the technical resources which are available with the college?
Very nicely drafted question. Basically, Kakre sir, Mehrotra ji pointed out that no discipline is difficult. Every discipline is equally important. Engineering is a broad subject which splits into many different disciplines, including chemical, civil, mechanical, electrical. Engineering graduates are often logical thinkers and excellent numerical and problem-solving skills. The careers open to engineering graduates are wide and varied. Although you may wish to choose the career most relevant to your engineering specialization and related to skills, this may require extra studying and work experience. So skill matters because disciplines are different, and in addition to skill, what type of satisfaction comes when you are doing the engineering? You have to enjoy the challenging work also. Discovering, Nikhil already explained, discovering new technological and scientific advancement, enjoying prestige, and taking part in a career that can be incredibly beneficial to the societies around the world. And in addition to these, what you mentioned, that placement records and accreditation. Yes, placement matters. Which companies are visiting your campus and number of candidates. Companies selecting the candidate based on the skill imparted by the institution. Then accreditation. How many labs accredited by NABL? What type of skills you are imparting in the lab, or whether NAC accredited or NBA accredited, what type of grades awarded? These are the rankings and matter. Whereas your second point is given is industry connect. Some of the institute recently started the industry institute interaction. Even 6-month internship is also launched by some autonomous institution, and they got the benefit. Internships converted into the placement, and placement scenario of that institute is changed. So industry institute connect and industry based projects also matter. Then third point was technical and technological resources available at the institute. So resources as well as the faculty capital. How faculty grooming and enhancement of faculty, or what type of faculty upgradation is available in the institute is also matter. So these are the things should student see what type of ranking of the institute and what quality of faculty, what type of infrastructure, what type of the equipment. even if software and skill-based courses available in the institute.
That would be a good this thing, like a small idea for the students to know or to rate or somehow get an idea of how to choose a college. That would help. Thank you.
Director sir, Untwala sir,
Yes,
so
sir. Yes,
please
sir.
excuse me, I have to leave sir. Kakle sir, please excuse me.
No, yeah, thank you. Okay.
Yes sir, thank you
Please,
sir,
please.
thank
Thank
you.
you. Thanks.
Thank
Thanks
you,
for
sir.
being here. Thank you.
Mr. Nikhil Malhotra, I have a question for you. Can you just enlighten us with some new emerging trends which are in engineering and technology and the scope of students when they are choosing the relevant courses like AI, machine learning, data science engineering? These are the trends which I know or are in progress, but maybe you could actually give a better idea.
No, so it's a mammoth question. I can't answer all of this, but I'll try and squeeze it into small little things. I think number one is obviously you said it to me. And I told you that COVID-19 has been kind of a chief digital officer for all of us. And it has changed the way we look at the world. It has changed the way we look at even the problem statements that we saw. Now, who would have thought Tech Mahindra as an IT services company and we in the Makers Lab would have actually studied the virus and gotten a therapeutic drug out of it? We have. We have a patent for a therapeutic drug that is actually down there, which is already applied for patent. But we studied the virus. So we actually shifted our branch from engineering into biology and back and forth, right? So is there a paradigm defined? I don't think so. It's going to be interdisciplinary. But some of the things that you would see in the future and the way you want to decide your future for kids is AI is going to be the next decade or maybe 5 to 10 years that you're going to see. No automation. And then remove the misnomeric terminology of AI and ML would be my ideology with students. A lot of people tend to confuse with machine learning and AI. There is nothing called an AI in the ecosystem. It's still going to take scientists. It's still going to take us another 40 years to produce a real AI system. It's all machine learning. Yes, machine learning. Please go ahead and get your hands dirty with machine learning. Now, what do you need? You need absolutely good mathematics, linear algebra, statistics, probability, and some part of differentiation, maybe not integration at this point, because a large part of it is differential that really comes in over there. So that's one portion that you're going to look at. Now, what are the things that you're going to solve if you look at this particular component? Supervised learning, when you type something on a Google search bar, things that come out is supervised learning. Unsupervised learning, where you can cluster certain things. But then the new age technology that is now coming in is the ideology of creating digital twins, which is reinforcement learning that a lot of colleges also skirt out. But I would request students to look at those areas as well, because that's what the industry today needs. Second, the transistor, as you would have read in your 12th standard, as well as the silicon, is going to have a demise in 2025. So when I say demise, you are not going to have much more crafted chips that are going to be lied down together. There's not going to be much enough VLSI integration. So for students who would have read Moore's law may end in another 4 or 5 years. And the reason for that is, if you go below 5 microns today at a quantum level, quantum effects will start happening and a lot of problems will start occurring with classical computation. So what's the next step for AI? If you want to improve it, we will go towards quantum computing. So that's the next era of growth that will happen. Third, our Indian defense and our Indian, the ecosystem today would look at machines and robotics in a big way. What's needed? Language, vision, tasks that the machine can do automatically. To Kakre sir's point, automation is still there, but in a very different way in which it is being produced inside of machines. And how do these machines become secure when you actually transmit data from one point to another? So that's going to be the third area where you're going to see a lot of change. Now, India is a boiling pot of all problems. When I say all problems, with massive amount of use cases and problems. 1645 dialects and 27 mother tongues in our country. And let me know if any Siri or Amazon Alexa or Google Home can solve this problem. So for students who have been using their phones, that's a challenge. That's an area where we now need more engineers in natural language processing, in vision to possibly solve this. And these are some of the areas that you're going to see massive, massive amounts of growth in the coming decade. So if you're choosing a field, look at not from the perspective of what that field today is. You may go into a mechanical engineering, you may go into civil engineering, you may go into computers or electronics. They are all going to converge to some of these problems that we are seeing in it. So eventually look at the vision or the horizon of India in the next 5 years.
That's like a holistic view to the whole perspective of all of those things together. Connecting to the same point, I am a GHRC pass out, and I'm proud to say that I recently found out that GH Raisoni was the first college after IIT Hyderabad to offer BTech in artificial intelligence. I was quite proud to hear that. So I'll move to Dr. O.G. Kakre. Dr. Kakre, what are some of the changes engineering education system is going through in the last 5 years? And how should a college ensure that they are actually able to keep up or equip their students to face the real engineering world?
Yeah, so I will request you to take a few more seconds than what you have permitted me. In my opinion, there are 3 major changes which took place in the last, I will not say 5 years, but in a decade. The first one is focusing on autonomy. The second one is implementation of outcome-based education. And the third one is encouraging the institutions to go for accreditation. I will elaborate upon this. All of you knows that India has got a typical graded system. We have elite institutions of national importance, starting with IITs, NITs, IIITs, then CFTIs, then state government funded institutions, then self-financing institutions, and like that. So except INIs, other institutions are majoritarily affiliated to some or other universities. Of course, there is a system of deemed universities also, state private universities, which came up recently. But majority institutions are affiliated type of institutions. And the problem with these affiliated institutions is basically no flexibility in curriculum design. And that's why we always talk about industry academia gap, the students are unemployable, and so on. So to deal with this problem, government has taken a decision that we will focus more on giving autonomy, and giving autonomy to majority of these institutions comes under the purview of University Grants Commission. And they were quite liberal in granting autonomy to many of the institutions in the last decade. Now, this when I'm talking about autonomy, I'm basically talking about academic autonomy. If an institution gets a financial autonomy along with academic autonomy, nothing like that. But academic autonomy is must, because to address this problem of industry academia gap, what they need is basically a freedom to design and implement their curriculum. So autonomy allows these institutions to design and implement their curriculum, thereby providing the required flexibility, required interdisciplinary approach, which will take care of addressing this industry academia gap. So this was one of the major changes which took place in the last decade. Of course, it is still going on. Then the second one is implementation of this outcome-based education. This is a paradigm shift. So in earlier dispensation, it was an input-based system in which we were of the opinion that if we provide a good quality teaching, the learning of the student will automatically take place. But it didn't happen over a period of time. And therefore, we were required to take a call on that. So what outcome-based education system is? It basically focuses on development of the required skills and the knowledge in the students. And the measurement of academic success is in terms of the students learning, not in terms of what inputs you have provided, or not in terms of how much money and time the student is spending in the system. Importance is given to the real results and not to the sweet intentions. Teaching is required to focus on learning, unlearning, relearning, and not only on teaching. And we don't differentiate between the students. We cannot keep on giving excuses that this institution is not getting the students belonging to top bracket and therefore we can't do anything. No, all students are treated at par. From the point of view of learning capability, and therefore all students are considered equal and therefore are worthy of the equal teacher support. So this is a paradigm shift in education system. And with the push from accrediting agencies like NAC and NBA, many of the institutions have started implementing OB. Of course, in many places it is in letters, but many institutions started implementing it in the real spirit. And if this OB is implemented in real spirit, I'm sure that the problems that we are talking about will definitely get addressed. And the third one is the encouragement for accreditation. So as on date in our country, there are two accrediting agencies, both are with the government. One is a NAC, which used to do the institute level accreditation. Another is National Board of Accreditation with a mandate to carry out program level accreditation, especially for UG engineering programs. And accreditation done by National Board of Accreditation for UG engineering programs for tier 1 institutions. So tier 1 are basically autonomous institutions, is considered to be an accreditation under Washington Accord. Is basically, so India is a signatory through NBA for this Washington Accord. It's basically the accord signed by different accreditors worldwide. And this establishes equivalency between the accreditation done by the accreditors who are the signatories of the Washington Accord. So accreditation done by NBA will be treated at par with the accreditation done by ABET, because NBA is a signatory of Washington Accord, and that's why it is really important. And nowadays, many students started facing the problem, especially in Gulf, New Zealand and Australia. They started asking whether the program was accredited or not. I started receiving mails from students past 30 years before, sir, whether my program was accredited or not. So push for this accreditation. These are the three major changes which took place in the last decade. And if the institutions really implements OB, go for implementing autonomy in true spirit, come out of that centralized mode and go for more decentralization, which autonomy permits, and take the accreditation process seriously, I think the problems that we are talking about will definitely get addressed.
Thank you, sir. The next question is Dr. Gadre. Since there are a number of different engineering courses, is there a specific or like a different skill set required for each course that one should think about when they're actually choosing the type of course that they'll be choosing in engineering? And when should they start enhancing their skills, when they actually start during the course of their period when they're studying?
Yeah, so let me first answer the question about whether there are different skill sets, right? Yes, there are definitely different, I would say, parallel streams of skill sets. I would put it this way. So let me list them. The first skill set, of course, is mathematical prowess, right? See, I can scarcely think of any reasonable command on engineering without sound mathematical understanding of the basic principles. And you see, one important thing about mathematics in engineering, as opposed to mathematics for the sake of math, in the sense the kind of mathematics that is pursued by, say, a person majoring in mathematics or doing a PhD in mathematics, is that you must be able to see the maths that you're using as a common abstraction from many different situations. Let me take the example of differential equations. You see, the mathematician looks at the differential equation as a challenge in itself. So now, I have two variables which are probably related through a differential equation, and I need to control one variable and find out how the other variable changes because of the differential relationship. That's one way of looking at it. But how does this translate into an engineering problem, right? So, I mean, do I see why do we abstract We abstract because abstraction allows us to deal with many situations at once, not bringing a situation where you can deal with none of the situations. You see, the problem is sometimes if we have not mastered our mathematics properly, we tend to think that it's only abstract. Well, abstraction actually is very powerful because abstraction allows you to deal with many situations at once. I'll give you another example. In electrical engineering, we often teach this subject called signals and systems. So signals and systems is a subject which is perceived by the maybe second year student to be a little abstract. They call it abstract, mathematical. Now, that is because you don't realize that actually signals and systems penetrates all engineering disciplines. So you can think of mechanical systems, you can think of hydraulic systems, you can think of course, electrical engineering systems, you can even think of financial systems, which all have the same principles of linearity, shift invariance, causality, stability, and so on, right? So and this is the first skill that is required, the ability to relate mathematical principles to the ground reality. I was talking in my initial remarks about the trichotomy, right? Science, technology, and engineering. So that I said one of the reasons why people go into engineering because they want to complete the trichotomy. They don't want to stay only at the science level, or they don't only want to do a hands-on kind of implementation with no understanding of the foundations, right? So it's a trichotomy which needs to be completed, and mathematics is the first stream. The second stream, as Nikhil ji very correctly said, is the ability to look into machine intelligence. He very rightly said that artificial intelligence probably is a far call right now, but machine learning is definitely something which is on the ground. And for machine learning, you must of course have computer skills, which means that that's a little different from mathematical skills, by the way. It's the ability to guide a machine through your intelligence. That is, you put in intelligence into constructing a code for the machine which it can execute. The machine by itself is not very intelligent, actually. It only does what its hardware allows it to do, at least as of today. Perhaps with quantum, things may change, because actually, in a way, quantum, I think I'm not an expert, but probably Nikhil can guide me. My understanding is that to some extent, quantum computing or quantum systems can actually bring in this slightly higher intelligence which our silicon machines can't, right? But anyway, that we can discuss offline. Whatever it is, the fact that a machine only works as much as its hardware and its structure allows you to, and you have to actually put the intelligence into the code that you feed the machine, is the other skill that the engineering student must learn. And that skill is not only in the domain of computers. You see, any machine requires a skill to operate, whether even if it's a welding machine or now, what is the intelligence that goes above just the structure, hardware, and the tools is what the engineer needs to bring. So that's another skill. The third skill is the ability to learn new things. For example, the ability to, typically we learn to analyze, but the ability to synthesize, right? So I have different skills with me and I need to synthesize them into building a system and then evaluating the system. This is a skill which also, this is the third stream of skills. Design projects, bringing people from different disciplines together. And as many of my predecessors, like Professor Kakade said, Nikhil ji said, Arvind ji said, there are different skills which come together to form most of the systems that engineers see today. And being able to synthesize, in addition to being able to analyze, is a skill that one has to learn. That's another stream of skills, right? Design and fourth, but not the least important, is as important as the others, is certain personal skills. So people, you must see all engineering disciplines have humanities courses, they have some kind of management training. Why is this so? It is impossible to keep growing as an engineer, as a technologist, as a scientist, as a leader, as a technology leader, as an engineering, say, supervisor or whatever, without imbibing personal skills. what kind of skills, different kinds of skills, communication skills, empathy, the ability to understand human nature, the ability to understand human computer interaction, the ability to, in fact, even deal with groups of people at once. It's not an easy, see, humans are much more complicated than machines. So being able to deal with humans as a group is a skill, and humans as an individual is a different skill. So, this is a fourth stream of skills. I'm sure there are other streams, and, I wouldn't want to hog away all the time. I'll let my colleague, I think Arvindji is also going to add to this.
Yes. So I would want his opinion on the same topic from the industry perspective as well.
Yes, yes.
Yeah, thank you. And it is always a pleasure listening Dr. Gadre and all the occasions. It's so beautifully explained, and I'm pretty sure all the students and the parents who listen to Dr. Gadre, it is a privilege. And
Thank you.
so I just add on what Dr. Gadre mentioned, and that so certain things are basic and applicable for all engineering streams, right? So engineering, as Dr. Gadre said, that it's all about a problem solving that is faced by the humanity and that is in and around you, and probably somewhere at a distance as well in the world, with the help of the tools, methods, processes, and the technology. So the first things that we all engineers has to develop, or budding engineers has to develop, is the problem solving skills. But how do you actually acquire these problem solving skills? That is easily said than probably done. An important thing is that, are we curious? Are we observing? Right? So very first thing is that let's be curious. Let us be observant. For example, I'll just give you an example that if you are interested in cars, oh, I want Jaguar, I want Land Rover, I want Volkswagen, and I fancy those cars. So if you are interested in the cars, automotives, in a larger context, then can you learn about the various cars just as a general knowledge through Wikipedia? How is Jaguar Land Rover, for example, different from Volkswagen, or Indigo is different from Maruti brand of cars? What are the features? How is one feature different from the another? What is the different components that make a car, right? So yes, we know many things which is there, but what are those components are? And can you go a little bit inside into that particular component and the whole body and electronics and mechanical of those body, right? And the different parts which constitutes a particular body, which is a car, right? And then probably you can look into the innovations and the creativity, some of the success and the failures that has happened in the history of that particular car itself, right? So get into that component level, and then, so essentially what I'm saying is that your ability to deconstruct and then see, can you reconstruct the same feature, or can you reconstruct the improved feature? So this is what is the problem solving, right? So it is not always a very drastic innovations and the solutions that is looking for, but incremental thought process towards solving a problem. That is what is the need as far as the engineering is concerned. So these are applicable for all engineering streams. In IT world, for example, how do we develop the software applications? We need to develop the context for a particular domain. If we are going to develop the software applications for a banking, we need to understand what is banking is. If we are going to develop a software for insurance segment, we need to understand what this insurance domain is. Or if we are going to develop certain softwares for the soft floors, we need to understand what are those processes that constitute the soft floors in a factory, right? So those developing a context becomes very important. And so that is where, if you look at this is a convergence between all the engineering streams. But then there are certain things which is a specific, like for example, if you've gone for an IT or computer science, you need to learn something which is relevant for IT and computer science. For example, you need to learn programming languages, data structures, algorithms, then you should learn about all those things, right? And similarly, there could be something specific that is needed for the mechanical engineering or civil engineering or electrical engineering that you need to know that, right? And the third element, which Dr. Gadre mentioned about the soft skills, right? So especially in IT, we all talk about that, yes, soft skill is very important because the fact that as an engineer, we have to interact with the humans, the other community, whether that community exists in the same country, same region, or could be across different part of the world as well, right? So, and for that, you need to develop the methods of a communications, and that is, and collaborations, how confidently that we are able to communicate. Many of those things actually form the soft skills. So some of these things that if you, and it's not that you start focusing only after third year and fourth year. Many times that we do a mistake is that, yes, now I am in third year and fourth year is when I'm going to focus on these skills. No, right from the very beginning in the first year itself, you form a committee, you form a club, and using that particular club, choose a problem statement which you are passionate about. For example, I'm passionate about the environment. I'm passionate about the wellness. I'm passionate about a car. I'm passionate about movies. I'm passionate about toys and the games. So develop a use in that particular passion that you have, whatever the engineering streams that you are in, what are the things that you can apply there? What are the innovations that you can bring in? Can you solve the problems in that particular domain itself? Think from that itself, from the first year and the second year itself. It's not necessarily that every time you can learn what is there taught in a subject, in a book. There could be something beyond the classroom. There could be some things that you can then beyond the defined curriculum as well. And that you can probably achieve through an informal club formation as well. And many of the engineering institutes and GH Raishoni for that particular matter has those kind of a clubs. Participate in those clubs, and using that particular club, bring into action your passion and whatever that is being taught in those first year, second year, third year, and fourth year. So that's certain perspective, Kritika, from my end.
Thank you, sir. I'll come back to one more question, the next one again to you. But before that, Mr. Nikhil, I have a question for you, which is, in theory, there are a lot of things that we study which are quite different when we actually go to an industry. And what are it of like, what do you think the industry expects from a student when they actually come?
I can give you a one-word answer and a whole paragraph, but I'll be just copying Dr. Gadre over here. But anyways, by one paragraph, one word for it is passion. The industry only needs you to have passion. That's it. The rest of it is trained by the industry. But I think I'll go step by step because students are listening, and passion may be a bigger word in a much more philosophical sense. But like Dr. Gadre said, basics need to be clear. You need to have basic mathematical skills as well as now physics skills as well. It's becoming important. With quantum coming into the realm, physics has become important to actually get there. Now, number two is how do you do and what time do you do internship with the industry? It's very important. Go for internship. Tell your college that I want to go into a 6-month internship because it does two things for you. Number one, it gives you the ability to look into a corporate structure, but also work at certain projects in terms of research or not research, or maybe some of the other work that the industry is doing. This will give you a good idea within 6 months what the industry needs. And of course, the next step is either go for an employment or go for a startup or whatever. But the most important factor is try and pick out one problem, as Arvind said, and say whether you can pursue your next 3 or 4 years in terms of that problem, because that will give you that mindset to look at the why of it. Now, turning it around, I have a book which is available on Kindle. I've written that book. It's actually, converting it all together. This is what the industry needs. The industry needs something called courage, and that's the book. 12th standard students can read it. Courage basically does not mean strength of the mind. Courage really translates into all the things that Dr. Gadre said. C, collaborate and communicate. O, make sure you objectify technology. And when I say objectify technology, unless a human being touches and feels that technology, your technology lies wasted. So make sure that you do whatever you do. You apply a bigger concept, you apply a smaller thing, make sure it is in the hands of a human being to try it out. Agile principles of trying it out. You means you are the maker. And it also goes back to your question, why engineering? Because engineering is one area that will have that tautological approach for you to create something of your own, and you will have that sense of achievement saying that I've created whatever small or big it may be. So you are the maker. R, rewire your psyches. See, the heart is an organ that continues to pump blood 24/7. What needs rewiring? The brain. So you've got to rewire it to understand where the problem lies, why the problem lies. A, it's a very simple concept that I use in my work and my R&D lab, which is called asking stupid questions every day. A means that, and it's very important. You may have a frown upon from your friend. You may get your parents to say, "Boss, itna bhi nahi janta hai, ye kya question puch raha hai." There is one advantage to asking a stupid question every day, and this is a practice at Maker's Lab. You tend to simplify a complex concept which is lying in front of you, and sometimes answers come very, very simply. G is obviously your goals. All of you would have goals, but E is called empathy. Most colleges and most teachers will tell you be empathetic to the other person in front of you. We teach be empathetic to yourself first. It's when you go into a plane and the air hostess actually announces that put on your mask first before you put on to a baby or an infant. It's about your mask first. Don't shy away from being empathetic to yourself, because there are potholes of despair in engineering journey, even in an innovator's journey. When you fall into those potholes of despair, it is that empathy that is going to pull you up. So courage is the only thing that the industry needs from us.
Very well put, especially in one word, it actually comes out in a good way. Mr. Arvind sir, if you could actually give your opinion about the same, please.
Sure. So definitely, and in fact, Nikhil has beautifully covered, and some of the points even Dr. Gadre mentioned and Kakre sir also mentioned about it. But let me cover a perspective from employment point of view, interview point of view, right? So what is the expectation of industry from the engineering students, right? So, and especially the core engineering disciplines versus the circuit discipline as well. So if you look at from an employment perspective and job perspective, there are many common things which is asked, right? It is like quantitative analysis, qualitative analysis, right? English as a comprehension that is being asked, right? And then there are some things which is specific. It could be specific to a particular industry, specific to a particular engineering streams. So can those common stuff, which is a quantitative analysis, quantitative reasoning, qualitative analysis, English as a comprehension, can be acquired in those 3 years, 4 years itself, right from the very beginning? Can you work on that, right? It's easy. It's very possible to actually do all of acquisition of those particular skills. And then definitely, if you, for example, switching from civil engineering to an IT industry or mechanical engineering to an IT industry, then you must know some of the aspects of the IT industry as well, right? If you are getting into IT, then probably there could be an expectation of a programming. There could be an expectation of some of the automation too. Like, for example, mechanical engineers should also know, as I was mentioning about these AutoCAD and SolidWorks and Rhinos, Adobe Creative Suites, Katia Creo as well, right? So those knowledge and should be there when you are appearing for example, if you are a civil and mechanical and electrical engineering appearing for an IT organizations, right? So that is what is that will help you to qualify the interview process. Otherwise, as Nikhil mentioned, it is all about the passion, it is all about the courage, it is all about the problem solving the skills that you have, and soaking yourself in the industry. And GH Raisoni is one of the institute where 6 months internship is there for almost all the engineering streams, and it is one of the pioneer institutes to move from 6 weeks of internship to the 6 months of an internship. And I have seen a difference in the students when they come to the industry. in TCS Nagpur itself, for example, every year we have 200 interns, more than 200 interns. They intern in TCS Nagpur campus, and they come from the various particular streams. And when I see the transformation of these students when they come into TCS and when they exit at the end of the 6 months, because of the fact that it's not that they were they didn't know about it, but here they were able to contextualize the knowledge which they acquired in those 3.5 years, right? And here they can also got an opportunity to apply how the customers are looking for, how different industries are looking for, how do I articulate that particular problem statement, how do I articulate the solutions which I'm thinking about it. As Nikhil said, that no question is a stupid question, right? That is the first things that we actually tell all the students who are coming to TCS, that yes, no question is a stupid question. If you are a software engineer, the very first thing that is expected out of you is to ask questions. So get into the habit of asking questions. Yes, we as a country, probably we are taught not to ask too many questions. Listen and obey, right? But probably when you are getting into the professional journey, you have to get into a little bit of different gear of asking question as well, right? And for that is what I suggested, that get into some kind of an informal clubs like Toastmasters Club, or for example, some innovations club and all of those. That will help you to table the problem statement, that will help you to deconstruct and reconstruct the problem statement and the solutions, that will help you to articulate around the problem statement. Government of India has launched the hackathons. Government of India has launched Toy and Gamma Toyathon and many such kind of hackathons which is there, right? Today, many of the organizations, when they are hiring, they are not just hiring based on the written test and as well as only the interview. They give you the hackathon, a problem statement, a case study to solve within those 3 days and the 5 days or 2 days itself. So you should have an ability to actually think through. You should have an ability to research both the secondary and the primary research, and then take a right approach towards solving a particular problem and table the solution as well, right? So some of these is what I'm seeing as a trend. And as we move into the future of jobs, and we see that a lot of digital forces have come into play, which Nikhil has very aptly illustrated around the machine learnings or AI, data science, big data, and Internet of Things, and many such kind of stuff that is already in play, right? So those are going to be there. So be aware about all those terms and technologies. Develop what is the passion and where do you have a passion. Those intersection point is what you can probably do much better and bring a career and bring a success and happiness for yourself.
Thank you, sir. That's a very good. I have a question for Kakre, sir. Human values and ethical practices are now becoming part of the engineering course. This shows a vision of building a more reliable professional and an ethically inclined professional. Can you share your views on this as well?
Yeah, definitely. This focus on humanity, having more humanities component and value education in engineering curriculum is gaining importance nowadays. And it is focused on our new National Education Policy 2020 also. Actually, this is not only required for creating better professionals, but this helps in better implementation of what I talked about OB also. Because in OB, we talk about use of different pedagogies like cooperative learning. For successfully implementing cooperative learning, students need to understand the importance of relationship, recognition, and caring for others. Similarly, to be a more ethically inclined engineer or to be better professional, one need to understand these things. The reason is all of you knows that our society has undergone a transformation because of advancement in technology and globalization. And this societal transformation is creating new social, cultural, and individual needs as well as challenges. And understanding these needs and challenges is must for an engineer to work in today's global knowledge society, because this will help him avoiding any unjust outcome of his or her professional activity. And therefore, it is mandatory to focus on teaching professional ethics, imparting value education to ensure that while carrying out any professional activity, the engineer should behave in a socially acceptable manner, recognize the dependence on others, caring for others, etc. Thank you.
Thank you, sir.
Ritika, if I may add something over
Yes,
here,
yes,
I think
please
the
do.
industry,
Please.
the industry is actually looking towards it, where we are essentially saying that it is now mandatory for us to essentially look at responsible use of technology, and that is where ethics really tie in and bind in. I know medical profession has always got a Hippocratic oath. We don't have that, but that's an implicit oath now with the kind of advancement. And for students who are actually listening, there are myriads of examples where we are actually seeing a lack of that responsible touch. For example, when you go to an ATM machine and you can actually get a kind of a loan discount or waiver, what should the machine really think about before it gives that loan and waiver? Is your past education enough? Is your cultural setting enough? So all of those questions have now started coming up. For engineers, it has become critical to understand that responsible use of that technology has become pivotal in the world. When I do a kind of face recognition for you, can I utilize that face recognition from AI in a bad way? If a self-driving car is actually driving on the road and it's suddenly faced with a passenger in front, or let's say a pedestrian, should the self-driving car brake and harm the passenger on board? Should it actually go ahead and hit the passenger or the pedestrian on the road as well? These are questions which have now become quintessential for the industry to understand, and also for the next breed of engineers coming in. So if they have this in this implicit mind of theirs, right, I would use technology in a responsible way. I think that knowledge itself is critical and essential for students to join the industry. The industry would pay a very, very higher focus for students who are who have that kind of a feeling of responsibility of technology, and also about sustainability. For those students who want to learn this sustainability goals, there are 17 marked by UN. The way we use energy today has become a kind of a challenge for our planet. It's become non-reversible. So we as engineers, we as technologists, we as scientists have a big, big responsibility on our shoulders to ensure that that is taken care of as well. Because we are leaving the planet for somebody else. We are not keeping this planet for our own. So I think that is absolutely critical for every student who's actually listening to this, right? We will give extra marks if you don't know the concept, but if you know the responsible part of a technology.
I was a little surprised when I actually heard about this, that it's becoming part of the course. And I didn't know that it would actually get assessed. But now that I'm listening to all of you, now I understand that, yeah, it could be something which is very important at this point.
So companies are now earmarking chief ethical officers. So industry is saying that we will have a chief ethical officer as a post in the organization to ensure that we follow the ethics and responsible use of technology. So that's the change that has happened.
So the next question is to Dr. Gadre sir. We had a small discussion before, but this is about the newly launched the national education policy, and that they had an option of multiple entry and exits that have come as a part of the new education policy. So do you think it could be something which would be beneficial for the students, or how could it actually make a difference? Or if you could just give an opinion about the same.
No, I must mention that this policy, this particular aspect of the policy, the multiple entry and exit, is probably yet to be implemented. Am I right, Professor Kakre? I think I'll just confirm, because we haven't really implemented that in the system, and I must actually applaud the thinking behind the policy. I think it will definitely be beneficial if it is implemented correctly. But the implementation is very critical here, because if the multiple entry exit is not properly thought through, it can create a huge amount of confusion. At the same time, if a complete thinking through is done, how one can implement the multiple entry exit processes, how one can ensure that it does not create inequities, I mean, there are so many possibilities of creating situations where there are paradoxes because a student gets into something and then enters something else and exits somewhere, and then what degree is the person finally going to acquire and so on. So I think it requires a lot of thinking through. And my remark at this point, since it is still in its nascent phase, is that in principle it's a wonderful idea. I think the students can benefit a huge deal from it. In practice, a lot of thinking, a lot of careful planning is required for implementing it in such a way that it becomes beneficial. So that's my response to it. I think Professor Kakade should respond to this, since he also has administrative experience, dealing with institutions of stature, more than one. In fact, he has now led more than one institution of stature. So I think he can remark on what would be the implementational issues, and does he think that it has already been implemented or it is still in the nascent phase? I think this remark would be valuable from him, this particular aspect.
Few institutions and universities have started implementation, but not by majority of the institutions in the country, because the modalities needs to be worked out. Because when we say multiple entry and multiple exit, the rationale behind it is that no learning done by the student should go west.
True.
So when we admit the students, our experience is that sometimes, for the reasons best known to all of us who are in academia, students are not able to cope up with certain courses and all those things. So student goes up to second year, then he finds a problem. And then we start receiving calls from the parents that my ward is not doing well, what to do and all those things. And we are left with no option, because as on date, what we are implementing is that unless you complete the credit requirement, you will not be getting a BTech degree or so. So whatever learning the student has done, he might have scored a good grade in a mathematics course, might have scored a good grade in a programming course, but may not be doing well in some other courses. And because of that, things are getting delayed, and then he goes into a psychological depression and all those things. So to deal with this problem, I think this multiple exit is a very good option. So what NEP 2020 is talking about is that if a student has completed these many credits, he can be awarded a certificate. Then with a slightly higher credits, he can go away with diploma. So somewhere there will be recognition of what he has already learned. That is the rationale behind it. Similarly, multiple entry, when you are talking about, student can enter at different levels also. But see, as Professor Gadre pointed out, I mean, it's difficult unless we have a well thought of process for implementing this thing. Like if I take an example of INIs like IITs and IITs, we are admitting the students. IITs are admitting through JEE Advanced. NITs, IIITs, CFT are admitting to a JEE Mains. Now, how can IITs permit a student at second year level? I know that in many state colleges, lateral entry of diploma holders is permitted, but this is not possible in INI's type of institutions. So they will have to work out the strategy. Because when the student will be entering, there is an issue of equality. He should be at par with the student who has cracked the JEE and entered at first year level. So these are the issues which needs to be worked out. So it will take some time. The idea is really good, but it needs basically details to be worked out, the modalities to be worked out, because I already made it clear in answering one of the questions that we are having this graded system. All the institutions are not at par. If that would have been the case, implementation would have been simpler. Our entry level criteria are different for different institutions, like states conduct their own CETs, then JEE, deemed universities have got their own entrance tests and all those things. So this is creating all sort of problems. If there would have been, I mean, all the institutions would have been at par, it would have been easier. So this is what is the state, but people are thinking, working on that. But definitely the idea is good, and if it is implemented, it will benefit the students. Thank you.
See, Kritika, in fact, I can add, see, one thing is, I'll share with you, even for example, in the IITs, now there has always been this issue of, as Professor Kakade says, students having, heavy skills in one direction and then perhaps finding it difficult to cope with some other kinds of subjects, and then running into a difficulty because the degree demands that they have all of these. So in that sense, the IITs also have been, as they say, at times I think building what I would call band-aid solutions. You try and find out ways, or even other institutions. I think they've been, wherever there is academic autonomy, they've been building what I call band-aid solutions. You try and somehow find ways of letting the student complete by. So I think in a way, this multiple entry, multiple exit system would address that issue. So I would, as I said, once again, I would reiterate that in principle, I think it's a very good idea. In practice, as I said, and as Professor Kakade also confirmed, we would really need to think through the details, because this can't be done in a haste. It cannot be done superficially. If it is done superficially, it will actually be a mess. If it is not done, again, it would be very, very tragic, because I think it's a very important concept to have in the new education policy. But I believe that this should really be thought out, thrashed out, with many different leaders of institutions sitting together and working out the details. So the devil is in the detail, as they say, here. And that's important to banish the devil, so to speak.
For the student, it's quite beneficial, but maybe for the institutions and as a whole, as a policy to implement it, it will require a bit of time.
Yeah, even for the institutes, it's beneficial because it brings a certain diversity, a
Right.
certain set of
Right.
possibilities which otherwise was not there very easily. But as I said, it would really require the institutions to brainstorm and do it carefully and meticulously. It can't be done haphazardly. If it is done haphazardly, it would be a mess. If it is done carefully, meticulously, and thoughtfully, it would be a great boon. In fact, in some sense, India can be a leader in education.
Okay. So the next question I'll ask Mr. Nikhil Malhotra. We have spoken a bit about it earlier, but internships and industry-based research projects. How do we, I know we've spoken a bit about it, but how could it actually contribute to the career and how does it contribute to the innovation that is done post-engineering or during the course of engineering?
Yeah, I think I've already explained this, Kritika, in one way or the other, but I think, and I think my esteemed panelists, all of them have explained that it gives the student the ability to think beyond the usual, subject that is there, because most of the researches that we do with the academia, with institutions are more multidisciplinary. For example, if we are researching on a drug of a molecule and also doing molecular dynamics and analysis, it does not just require a data science person. It also requires a biological, a guy who has biology as a backend. It requires computational biologists to, so students get to work in these multivariate teams. For example, the way we are essentially now researching with the College of Military Engineering in Pune, we are essentially thinking of certain very, very core concepts with the defense. And, it just does not involve one core component or proponent of it. It may involve a multidisciplinary facet to it. So what students really learn when they actually get this is, of course, obviously there's a value that students can actually publish papers, they can go to forums, they can present it, and they've done work with the industry, and that's also counted on their resume. But I think what they really learn is the art of design thinking, which is critical and very, very important when students actually get out of the college and go to an industry. We've been largely, and I keep joking, we've been largely in our technical field, and diaspora in India have been like a medical shop, right? So you come to me, even if one of you sneezes today, I will have about 3 medicines available for me, right? I will give you those medicines also. I'll say, please take this, please don't take this. It seems as if your cough is getting bad. So we've largely given solutions like this. But today, time has come where technologies become ubiquitous. People now can learn not just from their colleges, but also from varied lectures from different sources across the world. So technology is not a problem. The what and how is not daunting. The why seems to be a challenge. And that why can really get in when you get into these multidisciplinary researches. And when you get into those researches, you find out, hey, I've been thinking about this. This was taught to me, but practically it doesn't apply the same way. So maybe I need to shift that thinking process a little. So that is basically the culture of innovation. And that is something which breeds in the culture of innovation as well. So the student starts thinking in a completely different format or a fashion when they actually leave the engineering college. Right? So otherwise, it's like a plain simple line there.
No, it's like even during my engineering, whatever I had learned, when I actually went into the industry and found out, I was like, okay, this is something which is very different, looks very different from theory, but ultimately it was all of it implemented in a way that needs to be looked into in depth when you actually are there on ground.
I know, absolutely, absolutely.
So, Mr. Arvind sir, I have a question for you. You've spoken about this earlier, communication skills, soft skills, life skills. Do you think that these skills should become part of the curriculum in a way that they get introduced in the engineering as a course?
Yeah, and in fact, Professor Gadre and Nikhil and everyone talked about the soft skill part of it, right? Elements of courage, confidence, communications, collaborations, and all of those. And in all the engineering streams, we do have the courses around it, right? Humanity courses on the humanity and the business, English, and some of these courses are there. Uh, that is to bring a focus that this is important. However, if you look at the soft skills, it is a kind of an habit, a kind of a change that you have to bring, right? From whatever that you have been versus what is the need of an industry, and how do you develop it? And it can be developed over the months and years, right? It cannot be taught only in one course. So from that is where actually I keep on emphasizing on some of the informal method of learning these soft skills, right? The method of developing certain clubs within an organization, in an institution, and using those informal platform, you develop some kind of skills like communication skills, and it is not very difficult. Some of the examples I always quote is that a person who is coming from a rural background, he might not be very good in English when he is getting into an engineering streams. But if he goes back to the books of the class 5th and 6th and 7th and 8th, the sentences and the words and the paragraphs and the questions which used to appear very difficult at that point of a time, the very fact that now it is you are in a different stage of an age, you would be able to acquire it probably in a day or 2 days and 5 days and a week time frame itself, right? So if you really want to work on the communication skills, then probably you have to go back to the basics, right? If you go back to the basics, you would be able to develop the communication skills. May not be flowery English, but you can still be able to articulate what you want to articulate in a very, very simple sentences as well. So that is an important aspect, right? And that can be done right from the first year itself, right? It is, do not have to wait for third year and fourth year to start working on it. Okay. The second is that as a keep your senses alive, and when you keep your senses alive, you develop the ability to do a problem solving, right? How do you develop that problem solving skills? Today actually the world talks about a design thinking, right? How do you deconstruct and reconstruct some of the problems and the solution? And many of the things that you will be able to develop if you keep your senses alive and probably learn from the flora and fauna and insects and the trees and the plants and the whole of the nature which is there in and around us, right? For example, do you learn some things and draw a correlation between the aeroplane and the birds? And what is that methods of physics and some of the things that you can learn from that? Do you learn something from ants? Do you learn something from the bees? Do you learn some things from a kingfisher and a bullet train, right? Do you learn some things from a spider and a robotics, right? So many such kind of a parallel if you start drawing from the actions and the locomotions of the various insects, various reptiles, various animals, and the human beings. So that will help you to develop that problem solving skills, because at the core of the problem solving is developing the empathy. So if you develop the empathy of certain actions which is in and around, then probably you can apply whatever that you are teaching and learning, and then you develop that problem solving skill. So develop that. And that is true for any of the engineering streams per se. So soft skills, communication, confidence, courage, problem solving skills, design thinking, all are very, very important. Nikhil mentioned and stressed many times over, Professor Gadre mentioned that, Kakade sir mentioned that, yes, that is very, very important. If you know many things and if you're not able to articulate, it comes to the naught, right? So that's very, very important that you learn that particular skills. It is extremely important, extremely important.
No, I'll just add one more thing, Kritika. In fact, the fact that you are today, we are actually on this channel, we are using our laptops, we are using our phones, is actually biologically inspired. So Arvind is not on the target. This is called biological design thinking, where you actually look at biodiversity and apply it. All machine learning has been inspired from human brains. Right? We were, it was always separate. Neuroscience and AI was kept separate. Now we are actually mingling those two fields together. The bullet train in Japan runs because the design was inspired by a kingfisher, a diving kingfisher inside a pond of water, and it doesn't make a lot of sound or noise as it dives. So they wanted to reduce the volume as well. So if you see around it, to augment to what Arvind has said, and he said it beautifully, that if you see around you, you will find problems. And you would also find that nature has given some kind of a solution. If you can take that nature's biodiversity and put it to your thinking, you're actually through within the engineering piece. The rest of it is all formulas, theories, and what we do on top of it. Right?
True, true. Dr. Gadre, do you want to add something to this?
Yes, very often in the engineering formal education, we tend not to give what Nikhil and Arvindji said, this needs to be given a special impetus. I think very often I feel that, in the process of formalism, we tend to suppress creativity. Whereas actually formalism should enhance creativity. So my view is that it's very important for students to realize that even if they are in a formal setup of education, whichever, and by the way, whichever formal setup of education, if you notice some of the people who have reached heights in their careers or, built huge companies or succeeded in their profession, have come from such diverse sets of backgrounds. Some of them are engineers, some of them are, they might have been science graduates, they might even been arts graduates, and whatever. So, they could have excelled in a field of engineering by virtue of having observed nature around them. I think Arvindji said very correctly, observe nature around you. Nikhilji also said, it's very important for you to see, to translate what nature teaches you into what engineering has taught you in your formal process of education and so on. The formulae and the principles follow, but being able to connect them to what nature has, the intelligence that is inherent in nature. See, we tend to think that nature is not intelligent. Actually, nature is much more intelligent than us. Our intelligence is only a fragment of what nature has in its intelligence. And if we can only connect to that intelligence which nature has, then we can probably work wonders. So in a way, I would say that ability of the engineer, the technologist and the scientist to tune into nature's intelligence is something which education needs to give.
This needs to be formalized. Well,
this needs to be formalized.
Engineering graduates now need to have a formal education for this, rather than that we learn it when we go into the industry. Right?
Correct.
One of the other fun facts is that 60% of Silicon Valley founders are all art graduates.
Oh, so, that's remarkable. I didn't know that. I see.
You run companies which are tech, but you come from a marketing and an art background, which means what? That if an art graduate can actually run an engineering company, an engineer can definitely do it because they now know the nuts and bolts. It's all about connecting the two worlds.
So, I am done with my questions, but the audience has posed a few to me, and I'll just ask one or few of the questions which have been given. So, there's one of the questions from the audience is that, is it necessary to know how to use the programming languages at the basic level before joining engineering?
The programming language is being taught now from class 8, I assume, right? CBSE courses and some of the courses that I see. So programming language is just going to be like physics, chemistry, and mathematics in the current context and going forward. Okay, so you learn programming language just as you have learned biology or physics or chemistry and mathematics. It is needed. As I said, that automation is needed. It is getting into, it has already got into in every stream of engineering. In fact, beyond engineering, in biology and hospitals and the doctors, everything has got automated, right? So it is, if you develop that programming skills and essentially logical reasoning skills, then you are much better positioned in whatever the streams, the core streams that you choose.
But I don't think it's mandatory to enter an engineering college with a programming. I think the engineering colleges would actually train you with all of that stuff. I'm presuming at least C, C++, Python, the basic construct will be taught by the engineers. So it's not mandatory. But I think it's important in certain cases because we have now seen physicists using computations and they write their own programs. We've seen biologists today write their own programs. So why not engineers? Because you now need to control larger machines, right? And better machines. It's mandatory to get out of engineering with some kind of programming degree, but it's not mandatory to get into engineering and no programming. That's not it. Even though Arvind said rightly, white hat juniors of the world are now teaching 8-year-old kids. My 7-year-old has learned programming. So now it's a different talk that we can have. Right? So, but the idea is that that's different. If you've not learned, no problems. You can still learn it.
Is a master's degree mandatory? I wouldn't use the word mandatory, but still, is a master's degree required after engineering?
You know, I would put it like this because this probably also addresses the educationist more than, if you look at the words, actually, they are very suggestive. You say Bachelor of Technology, and then, you're still, Bachelor means, you still haven't got married to that technology at some level, and then Master of Technology means that, you I keep telling my master students, when you're going to aspire for a master's degree, you should have mastered that subject. That is what for example, in a master's, typically in a Master of Technology program, there is a dissertation component. That means a project, a person does a project over an extended period. And the purpose of that project is to master that field. It's not simply to execute a certain task which the supervisor has given you. That's not, see, that you anyway would do. I mean, as a technician would execute a task which the supervisor gives. A simple, person who is less educated would also execute a certain task given. That is, so when a person comes to a master's degree, the first thing that he must learn is to master that field. What do you mean by mastery? Mastery means being able to see beyond just what the textbook tells you. I would say that is mastery of the subject. See, in a bachelor's program, typically you have a set of prescribed course curricula. You have a certain syllabus which you need to master, and you've been able to answer questions. You've been able to create, to some extent, with your BTech project, you've done some creative work. But in a master's program, you should have gone beyond the level where you simply sit with your textbooks. You should have seen how those principles came. Now I'll take you one step further. You have the bachelor's program, you have the master's program, then you have a doctoral program, a PhD program. In a way, a master's program is a foundation for a doctoral program in most places. I would say that in most situations, one would want that many, at least a few selected master students move into a doctoral program, or at some stage complete a doctoral program, in their careers, whether part-time or full-time. And what do you need in a doctoral program? You should have made a difference to the subject. But to make a difference to the subject, you should have mastered it. So I would say that a master's degree is very desirable for somebody who wishes to reach senior echelons of leadership. I would put it this way. If you wish to reach senior echelons of leadership, some kind of training of the kind that you get in an MTech or master's program is desirable. But then, it's also true that everybody cannot achieve this because of various constraints. It could be, the fact that there could be constraints of having to earn and so on. And therefore, I would also therefore strongly advocate having master's programs which are part-time, but in no way compromising the quality of education. I personally am a great advocate also of master's and PhD part-time programs, particularly programs where the people working, professionals working in the industry, professionals working in general, in whatever way, whether self-employed or employed by an employer, come and complete a master's degree or later on even a doctoral degree. But for that, the philosophy should be clear. See, you shouldn't simply be, now for example, in the PhD program, let me tell you, very often people in the educational sector come to the PhD program because they require require a PhD for their promotion. Now, while I have nothing against, seeking promotion and wanting to earn a PhD because it enables your promotion, what I'm against is just doing it with that objective, because then your PhD also can only reach that level, right? So I think it's welcome to want to seek promotion in the educational sector and therefore come for a PhD, but then the philosophy should be understood. The reason why a PhD is recommended for promotion in the educational sector is the skills that a person acquires in a PhD program, the temperament, the personal evolution that one goes through in a PhD program is critical for the educational sector. And that is why, and if that is not completely acquired, then the PhD is not useful in the educational sector. So like this, I think it's important that the master's program also for all, I gave the example of the education sector for PhD, but the master's program will be very useful to most engineering, aspirants or to people who want to rise in the engineering sector. But it will be useful when they realize this philosophy, the desire to master that subject. The mastery which is required of a leader, the mastery which is required of a person of dynamic qualities.
So I have one last question. What makes a great engineer is for all, any of you could answer that question. Arvind sir, for you. Makes a great engineer.
I would say there is nothing called a great engineer, and probably I had answered that when I was giving examples about the nature, right? So nature is the biggest innovator. Mother Nature is the biggest innovator. Mother Nature is the biggest scientist. Mother Nature is the biggest engineer. So I believe that take some iota of whatever the inspirations probably you can take from in and around you from this nature, right? That constitutes many things, and get into the journey. Okay, this is a journey. This is not just one milestone, right? So be onto the journey, get onto the basic things which constitutes the engineering as a definition. I'm pretty sure you will always better your skills, and you will always be in the path of whatever the best as a definitions that you're looking for.
See, I have often told my students, particularly when I'm teaching a core course, a core compulsory course, that it is this has been understood in different ways by different people. For example, the psychologists and the people who have studied human mental faculties, I think, are unanimous that finally humans are able to use only about 15%. I think 15% also might be a bit of overestimate, but definitely not more than 20% of what potential they come with when they are born as humans. So, this is something which this is not just some philosophical statement. This has been well undocumented. Even very reputed scientists, very reputed intellectuals ultimately are able to use only about 15 to 20% of their actual abilities. I think Nikhilji can probably, I don't know, can comment on this. The human ability is, see, I mean, I remember one person, I think it was Gurudev Shishi Ravi Shankar ji, or I can't remember, but many of the spiritual leaders have said that see, it's like this. We are almost, it's as if that, we have a diamond sitting inside us. And it has been covered with so many layers, and we see only a small speckle of that diamond. So in each student, you see a little speckle, that because that part of it is uncovered. But there is a whole diamond sitting inside, which has to be polished properly. And in a lifetime, even in a lifetime, you will only be able to polish some part of it. So what does it mean? It means, see, where is this question? I mean, see, greatness, you are going to reflect only a small fraction of the diamond which is inside. Just polish a little more. Atmaiva Atmano Bandhu. So polish a little more and you can reflect more. So every person is potentially very great. And then that's my view.
You're absolutely right. And I think neuroscientifically, we only use 2% of our brains.
2%. So I mean, I was overestimating it by almost a factor of 8 or 9. Yes.
15% will all be geniuses. I think maybe Einstein didn't.
Yeah. So I mean, that's what I said. Even 15% is probably a huge overestimate. So.
But I think what makes a good engineer, that question needs to be rephrased. As all Arvind, Gadde Saab has said, it's not about being a good engineer. It's always being, or if you have to draw your vision to something, it's always been a satisfied engineer. And a satisfied engineer can only be one who's actually created whatever small, little, big, etc. that he wants to do in his life. And I think that is something that you want to achieve. You don't want to be a great or a good engineer. There are no great good engineers. It's all relative. You are greater than him, but you are not as good as this. That relativity will continue to happen in our lives, right? It's all relative. But be a satisfied engineer, that whatever I'm doing, I have full control of what I do, and I make something. And that is the endorphin or maybe the dopamine that your brain needs to make you sleep peacefully. That I've managed to create something of mine. That's it. It's a satisfied engineer.
Kakade sir, you want to contribute?
Yeah, I don't believe in this good or great engineer. In the Indian context, what I will say, the purpose of our engineering education should be to provide low-cost technological solutions to the problems that our society is facing. There's myriads of problems that Indian society is facing. So we want, basically, our engineering education should focus on that. We should not go for good or great engineer, something of that sort. To what extent it has happened, that can be debated out. Because even today, more than 70% of the Indian population doesn't have access to the safe drinking water. This is a fact of the matter. So we need to focus on basically providing low cost, this is very important, affordable solutions to the problems that our society is facing.
Thank you everyone.
Just add one word to it.
Yeah,
affordable but sustainable. Affordable solutions are very localized. Sustainable takes it to the entire country. So affordable but sustainable solutions. And I think Dr. Saab is absolutely right. That's the job, and that can make you a good, great, whatever engineer you want to add a term after that.
That was a nice discussion, although the question was very simple, but it added a lot of points into it. So as an engineer, the aspiring engineers, I would just say that have the passion to actually implement whatever you study during this course of time into something which will be seen in the future, held by people in the future, or like something which people will actually use, and look at it as something which is a problem solving, and increase or as many skills, as many things during this course of time, so that by the end you are somebody who has it all. I wouldn't say has it all, but somebody who is satisfied with whatever he's done during the course of period during the engineering. So I'll pass on. I'll ask Dr. Sachin sir, Director of GHRC, to please give a vote of thanks, please.
Yeah. Thank you, Kritika. Am I audible clearly?
Yes.
Yeah.
Thank you. Good evening, one and all present here. It is my privilege to deliver the vote of thanks for the virtual panel discussion titled Industry Education Vertex 2021, Engineering Your Career, conducted today by our Raisoni group of institutions. As we all know, the organization of such panel discussions are generally the result of close cooperation amongst several institutions and individuals. It is my great pleasure to express on behalf of Raisoni Group of Institutions and on my personal behalf a deep appreciation for the support and encouragement provided by the honorable speakers for the event. We sincerely acknowledge the galaxy of stalwarts who have graced today's event. I humbly thank Dr. Vikram Gadre sir, Professor IIT Bombay, for gracing the event and always giving us an exposure to the IIT system of thought process. His thought process is simply mesmerizing. Thank you, sir. We are also thankful to Dr. O.G. Kakde sir, Director IIIT Nagpur, for gracing the event. Dr. Kakde sir has always played a proactive role in the development of all of our RGI institution ever. Thank you, sir. A huge gratitude to Mr. Arvind Kumar, Center Head, TCS Nagpur, for always guiding us about the role of industry in institution, and most of our thought process has been implemented at all our institutions at RGI. Thank you, sir. Amongst the galaxy of dignitaries, we were delighted to have Mr. Nikhil Malhotra, Chief Innovation Officer, Tech Mahindra, and a TechDev speaker who lucidly expressed his views. Thank you for joining us, Nikhil sir. We express our sincere thanks to Dr. Manoj Naigawane, Joint Director, Regional Office of DTE Nagpur, for sharing his thoughts in the panel discussion. The moderator of the event, Alter Ecos India Private Limited, Ms. Kritika Dhanvate, needs a special mention for conducting the entire panel discussion so effectively. Thank you, Kritika. I'm feeling proud to know that you are an alumnus of our institution.
Thank
Our humble and sincere thanks are to Chairman of Raisoni Group of Institutions, Sri Sunil Raisoni sir, who has always given us a great vision to achieve laurels in the field of education. And my thanks are also to the Executive Director of RGI, Mr. Shreyas Raisoni, who equally works with us for achieving the vision of Honorable Chairman sir with a focused vision statement. We are also thankful to the principals, directors of Raisoni Group of Institutions for being a part of this spectacular event. We'll be failing in our duty if we do not mention a very important role played and the tireless efforts made by the young and dynamic team under the able leadership of Mr. Aditya Bhandari, Executive Director, Global Education Limited, Mr. Tushar Mule, Priyanka, Sindhu ma'am, and the entire team. They have done an incredible job. Thank you, Aditya ji and the entire team. It has been a real pleasure to work with these fine and capable resource people. We are extremely thankful to all the participants for attending this panel discussion. We are sure that there are many takeaways from this session for the students, those who are desiring to take engineering admissions. We are extremely grateful to all those whom I might have missed and have been a part of the event directly or indirectly. We also thank the press, print media for giving wide coverage to this event. And at the end, we once again humbly thank all participants and one and all present here, and salute the panel for providing inputs to the participants and to us for the future sustainable development of all the institutions under Raisoni Group of Institutions. Thank you. Thank you. Over to you.
Thank you, sir. It was an honor to be a part of this and to assist you with the entire process. And we're going to be doing this on and on because ultimately it's for the student behalf. I declare that everybody can leave the session and